When I published the second edition of Raspberry Pi Full Stack a few years ago, a current version of the operating system was Raspbian Buster. Python was at version 3.8.1 and the Raspberry Pi 4 was relatively new. It's now the middle of 2022 and my Full Stack app has been running for many years without missing a beat. Even though the application is working reliably, I decided that it's time for an update. In this update, I'll show you how to update the various software components in a disciplined way and with a minimum amount of effort. And by this, I mean that the update will not necessarily utilize the latest available versions of the components, but the latest tested and compatible versions. In this lecture, I'll talk about the new content that I've prepared for this update and how to approach this course if you're new to it or have already completed it. First, let's look at the changes that this update brings. It's safe to say that almost all of the software components that make up this application have newer versions. On the flip side, the hardware remains the same. I'm running or have tested the full stack application on an original Raspberry Pi Model B, a Raspberry Pi Zero, Raspberry Pi 4 and a Raspberry Pi 3. On the software side though, there's a new operating system and newer versions of the various components that are distributed as apt packages or Python modules. There are also newer versions of the Python 3 interpreter, JavaScript libraries and cloud applications. The operating system is a major component of our application. When I published this course, the latest version of the Raspberry Pi operating system was Buster version 10.1. Today we have 64-bit versions of the Raspberry Pi OS Bullseye version 11. Upgrading from Raspberry Pi OS version 10 to version 11 is a major upgrade. Doing this kind of upgrade in place requires the replacement of millions of files and changes in configuration. Much of the process of an operating system upgrade is automated, but getting the application that is running well on an old operating system to continue to function well under the new operating system often requires a lot of work that is difficult to standardize and document so that you can follow and learn from. One of my objectives is to do a disciplined and minimal effort upgrade, so I opted to upgrade the operating system to the latest available version of Buster, which is currently version 10.13. If down the track I choose to use Bullseye for the full stack app, then I'll start with a fresh copy of the operating system on a new SD card and build up the application from there. This is something that I've actually done, but I only recommend it if you're starting from scratch. And I'll come back to this point later in this briefing. Luckily, the Raspberry Pi OS is built on Debian Linux, which uses the apt package manager. The full stack application depends on the Nginx web server and the SQLite 3 database server, and those are easily upgradable with apt. I'm also using apt to upgrade the Raspberry Pi OS to version 10.13. The full stack application is written in Python and uses the Python 3 interpreter. After extensive testing, I found that the newest version of Python that does not break any features in the application is Python 3.8.13. When I published this course, I used Python 3.8.1. Unfortunately, versions of Python that are 3.9 or newer break the Python wrapper for the RF24 transceiver module. As I wanted to keep all of the functionality of the application, I opted to upgrade to Python 3.8.13 and not the currently available latest version 3.10.5. I'll come back to this if I find a way to successfully compile the RF24 Python wrapper with Python 3.10 or newer. Once I had found the latest compatible version of Python 3, I upgraded all other Python modules and tested that they worked as expected. With the exception of the Adafruit DHT22 module, it is easy to update the Python modules. The Adafruit DHT22 module requires a hack if you are using a Raspberry Pi 4, and more about this later. I also upgraded the jQuery, datetime picker widget and the JS time zone detect JavaScript libraries that the application uses in the front end. Everything worked well here, and I was able to use the absolutely latest versions of these libraries. Finally, the full stack application interfaces with several cloud applications such as If This and That, Google Charts, and Plotly. After updating the individual software components of the application, I restored and tested the cloud functionality. And I'm pleased to say that all cloud applications have made no breaking changes to the public APIs, so everything worked as expected. To help with the update process, I've created an update version tracker on Google Sheets. You can find this tracker by typing the short URL that you see on the screen here in your browser. Feel free to make a copy of the sheet so that you can edit it. I used this tracker as I was updating my own full stack application and captured the entire process in a new series of lecture videos. It contains before and after versions for the various components, information, URLs, and test and install commands for each one. I've recorded a series of new lectures to help you update your full stack application. You can find these lectures in a new section at the end of the course titled Full Stack Application Update. If you have already completed this course and you have a working full stack application, then you can consider updating it by following the instructions in the new update lectures. It's very likely that your starting point will be different to mine. For example, you may be starting from Raspberry Pi OS version 10.4 and Python 3.8.5, and that's okay. Be sure to start by taking a full backup of your SD card so that you can always start again if something goes wrong. I show you how to make and restore backups in the first part of the course. Once you have your backup, begin the update process as I am showing in the new lectures. If you are starting this course now, you obviously don't have a full stack application to update. As you are starting from scratch, you'll be getting the latest versions of the various software components by default unless you specifically restrict the component version using the apt and pip package managers. Please keep the information in this slide in mind as you go through the course. At the time I'm recording this briefing, I've not yet added reminders about these points in the original course lectures, so please try to remember. As far as the operating system is concerned, it is okay to use the latest available version. I've tested with the 32-bit version of Raspberry Pi 11, Bullseye, and the application worked well. It's also okay to use the latest available versions of Nginx and SQLite 3. The APIs for these components haven't changed. Be careful with the Python interpreter though. If you want to use the RF24 transceiver, then the latest Python interpreter that you can use is version 3.8.13. Watch the two new lectures at the end of the course titled Update System Python to 3.8.13, and the other one is titled Update Python Virtual Environment to version 3.8.13 for information on how to do this. For most other Python modules, it's okay to use the latest versions except for the following. The Adafruit DHC22 module is fixed to version 1.4.1. The Plotly module is fixed to version 3.10. The RF24 Python wrapper and module is fixed to version 1.4.3, and finally the RF24 network Python wrapper and the module is fixed to version 1.0.17. For the JavaScript components, it's okay to go for the latest versions. In the update version tracker, you'll find command examples that show you how to restrict components to a specific version. Also, if you are using a Raspberry Pi 4, the Adafruit DHC22 library will require you to do a simple hack in one of the module files. The hack is required because this library was archived before the Raspberry Pi 4 came out, and then it was not updated to be able to recognize the new hardware. You learn how to get this library to work with the Raspberry Pi 4 at the beginning of the lecture titled Tweak the Application to Work with the Updated Components. I know it's a long title. You'll find this lecture at the last section of the course. Okay, so this concludes the application update briefing. Enjoy Raspberry Pi full stack.